Hello everyone and welcome to section 5. In the previous section we learned about HTTP middleware while creating a starting point for tracking analytics. In this section we'll be building a user login and authentication system. We'll start by looking at how to store usernames and passwords securely. We'll then look at how to send a password reset email, followed by how to store user sessions. We'll end the section by talking about JSON web tokens as an alternative to sessions and showing some ways Go can help you make your web apps more secure. Moving on to the first video, let's take a look at how to store username and password combinations securely. This video will be simple and straightforward. We'll see how to hash and salt a password and how to verify that password. In this video, we'll be using bcrypt to hash and salt our passwords. You'll need to get this library by running go-get golang.org/x/crypto/bcrypt. Once that's finished, create a new directory in our Go projects folder called users. Create a file named users.go and another directory called cmd that contains a file named main.go. This should feel pretty familiar by now, hopefully. In users.go, we're going to start by creating some places to store our usernames and passwords. For this, we'll use a map protected by a read-write mutex. Since maps aren't safe for concurrent use by default, we'd better protect it. We'll also create a method to initialize this store so that we can keep a reference to it. To create a new user, let's make a function that accepts a username and password. We'll also write a function called exists that checks to make sure each username is unique. Exist is simple. It just checks our map to see if that key has been used before and throws an error if it has. This line here locks our map while we read from it, hence the name rlock. We also make sure to unlock it after our function returns. To hash and salt a password, we'll use the bcrypt package's generate-from-password method. This will create both salt and hash for our password, which makes life quite a bit easier for us programmers. Note that it accepts byte slices, not strings, so you need to cast your strings to byte slices here. The second argument is just an alias for the amount of rounds our bcrypt function does. Using the default cost is strong enough that our passwords will be very secure. After securing our password, we just write it to our map. In this case, we've used the sync package's lock method, which locks our map for writing. That's it. To verify our password, we'll use bcrypt's compare hash and password method. For this, we need our hashed and salted password, so we'll retrieve it from the map using the username as our key. To keep this package's API simple, we just return nil if the user's password is verified successfully, else return an error. In cmd/main.go, let's write some code to test this out. For the sake of brevity, I'll just paste this in and then run through what it does. So, first we create a new user with the given password. We then try to authenticate that user, and if we're successful, we print a message to show that we're successful. We then try to do the same thing again, but this time we should get an error saying that we've tried to use a duplicate key. As a final note, depending on when you watch this video, it's possible that bcrypt is no longer as secure as it once was, thanks to computers continuously increasing in power. There's another key derivation called scrypt, which is said to be even stronger than bcrypt. If you'd like to use this, I recommend the library Simple Scrypt by Matt Silverlock, since its API is identical to that of bcrypt. In this video, we learned how to securely handle usernames and passwords. In the next video, we'll learn how to create and send a simple password reset email. Well done!